Hi everyone, my name is Samita, and today we're going to talk about the method of characteristics. The equation is usually of the form first derivative of tu plus a of x comma t, first derivative of xu is equal to g of x comma u comma t. We can combine the advection terms with the ODE terms to get something of the form u of x comma t is equal to u of x of t comma t, so that our equation is du over dt is equal to the first derivative of tu plus dx over dt, first derivative of xu. And du over dt is really our g of x comma u comma t term, which is our growth rate along a path. And dx over dt is really our a over x comma t term, which is the velocity of propagation. So we've successfully reduced our PDE into an ODE. Okay, it's time for an example. In this example, the first derivative of tu plus 8 first derivative of xu is equal to u. With the initial conditions, u of x comma 0 is equal to sine of x. Let's look for our a of x comma t term, which is equal to dx over dt. In this example, it's equal to 8. So we can write x is equal to x naught plus 8t. And therefore x naught is equal to x minus 8t. And that's an important equation to remember. That's our characteristic. For the same example, let's look for our g of x comma u comma t term, which is equal to du over dt, which in this example is equal to u. And from the first part of our course, we know that u of x comma t is equal to a e to the power t, and a is the constant of integration. So now let's find a. So we write as a is equal to a of x naught, and x naught is a variable that labels the characteristic. It's time to apply the initial conditions. So we can write the initial conditions as u of x naught comma 0 is equal to sine of x naught, which is equal to a of x naught, which is equal to sine x minus 8t, because we know x naught is equal to x minus 8t. And then finally we get to our solutions, which is u of x comma t is equal to a times e to the power t. A is a constant of integration, so we can write it as sine of x minus 8t times e to the power t. So intuitively, we can say that the information about the initial conditions is propagated along the characteristics, but u grows exponentially along the characteristics.